Okay, let's talk about decimal place value today. What do each of these numbers mean? What's the 2? Well, 2 is equal to 2.000. The 2 is 2. That one's pretty easy. What about the 4? Well, the 4 is actually 4/10. So that would be 0.400. 4/10. The hundredths, 5, well, that would be 0.050. Okay, that's what it's equal to, 0.050. And the thousandths, well, that's 0. I think you figured this out by now. 0.007. 0.007. That's the place value of the thousandths. What do these all mean? Well, it means this one is a lot bigger than that one, or that one, or that one. Okay? The ones are the big guy. So anything on the left is big. Okay? And it gets smaller as you go to the right. Think of it like this. This is like a full pizza. Okay? This is like a pizza where you get a tiny little piece. This is a pizza where you get the crust of a tiny little piece. And this is a pizza where you get to basically smell it. And that's it. Right? Lot big, much smaller. The crust of something smaller, and almost nothing. Like maybe a teeny little piece of cheese. Not even a full pepperoni. Okay? So that's what we're talking about for size differences. So even though this 7 is a big digit, right? 7 is supposed to be bigger than 5. Well, 7 mice are a lot smaller than 5 basset hounds. And those 5 basset hounds are smaller than 4 lions. And 4 lions are smaller than 2 elephants. You see what I'm saying? So big, big, big gets smaller, even smaller, so tiny. And anything past thousandths, we're talking really, really small. Okay, now let's look at these numbers. You might think, wow, this is clearly bigger because it has more zeros, right? Wrong! That's wrong! They're all the same because with decimals, anything to the right of the decimal, okay, these zeros mean nothing. Zip, nada, okay? These are all exactly the same. I could write 1,000 zeros. As long as they're to the right of the decimal place, they don't matter. Okay? As long as it's continuous zeros, it doesn't matter. So 3.6 is the same as 3.60 is the same as 3.600. All the same. Easy? Okay, let's talk about decimals in word form. How do we do word form? It's super simple. Here's what you do. First, you check the ones. If you got nothing in the ones column, ignore it. Then look at your decimals. Read the number like you would if there was no decimal there. 35. Then, after you've written 35, look to the far right decimal. This is our last one. So we say 35 hundredths. Pretty easy. Well, what if we had a 7 on the end? Well, now we have a new far right number. So we got to say 357 thousandths. And what if we get a number over here too? Well, now we got to tack him on the front. So now it's 8 and 357 thousandths. Dumbest word in the English language. I swear to goodness. Drives me crazy. Anyway. So, your ones, just put it at the front. Add an and, that's your decimal. And then say the number, 357, and the last place value, thousandths. Okay? You can draw this easily on paper and replicate what I'm doing. Ones, period, decimal, tenths, hundredths, thousandths. Okay? Easy. So how would you do one like this? 3 and 14 hundredths? It's easier than you think. 3 decimal, that's the and, 14 hundredths. So the last place has to be hundredths. So hundredths is right there, and tenths is there. Okay, that's about as tricky as it's going to get. Also, that's really close to pi. Let's try another one. Let's say you see 7 and 2 hundredths. Well, 7 decimal 2, right? Wrong, because those are the tenths, okay? It has to be 2 hundredths. So 0 tenths, 2 hundredths. And again, if you have trouble remembering this, just draw a chart. The chart makes it easy. The chart can save anything. We got our 7, our and our 2 hundredths, 2. And if you got a blank spot, that's a 0. Use your chart if you can. My chair's creaky. Okay? Try one more. Let's say you get 23 and 206 thousandths. Well, 23, and dot 206 thousandths. So 206, where the 6 is under the thousandths. Okay? There. It's going to take practice. It's going to take time, but it will make sense. Good luck, and God bless you.